Hi, my name is Don, and I have a project I'd like to show you. This is my first serious milling project since I bought my Tormach PCNC 1100 mill earlier this year, and it has been a real education. Most people are familiar with the fidget spinners that have become popular in the last 6 months or so. I bought a couple of them just out of curiosity and thought making one would be an interesting project. So instead of the usual molded plastic 2 or 3 lobe spinner you can buy at a gas station, this one is modeled after the flywheel you'd find on a 1 or 2 cylinder steam engine from the peak of the Industrial Revolution of the late 19th century. Since this is the first time out, I've kept it simple with solid webbing between the center hub and the rim of the wheel. The hub you see in the picture is threaded to accept what I call a bearing retainer cup, which houses a small ceramic bearing and threads in to hold the bearing tight on the outer races. Later versions may include spokes or some form of engraving, but this is meant to be simple, and for a beginner like me, it's plenty challenging. Oh yeah, I'm not a machinist, I'm an electrical engineer, which means I've had an enormous learning curve to get to this point. And I've had a lot of help. YouTube and Facebook are a tremendous resource. On YouTube, one of the most prominent CNC machinists out there is John Saunders and his NYC CNC channel. John is a self-taught machinist and entrepreneur who offers his YouTube videos on machining and Fusion 360, as well as in-house training at his shop in Zanesville, Ohio. I can't recommend John's channel enough as a resource. He started as a rank beginner with an idea and turned it into a thriving business. We can all hope to do as well. If you need inspiration, I recommend This Old Tony, who offers a blend of experience and humor to demonstrate making a wide range of things with not much more than a TIG welder, a manual milling machine, and a lot of ingenuity. His videos are educational and entertaining. They're not to be missed. Autodesk maintains an excellent YouTube channel supporting its Fusion 360 CAD/CAM simulation product, which it offers free to hobbyists and startups. The Fusion 360 channel includes step-by-step training for CAD modeling, setting up CAM, creating and running simulations, and getting your project ready to make and assemble. With the recent addition of sheet metal modeling to Fusion 360, there's little you can't do with this one package. And if you're a Tormach owner or considering purchasing one, Tormach's YouTube channel offers a wide variety of examples, basic training, and quick tips to set up and operate your Tormach CNC mill, lathe, or surface grinder. Tormach tech support is excellent, and they offer training classes as well as an annual open house to help their customers make full use of their investment. Let's get on with the fun part. With a piece of brass stock in the vise and the first tool in the spindle, the first step is to deck off 20,000ths of an inch with the Tormach Superfly to remove any irregularities in the surface of the stock. We'll do one pass 1100 RPM and 2.2 inches per minute. This works out to 2,000ths per tooth, which is not quite as aggressive as the Superfly is capable of, but gives a smoother finish. With the stock surfaced and ready to machine, we're going to do a 3D adaptive operation to do most of the material removal. The tool is a Lakeshore Carbide variable flute rougher finisher at 5100 RPM and 15 inches per minute for about 1,000th per tooth. Depth of cut is 1/8 of an inch. Width of cut is 1/16 of an inch. The video is sped up 8 times, so this video doesn't last the 47 minutes it took to finish this part. Rather than listen to me blather, I'm going to put on some music. We'll talk more at the next operation. The next operation is a 3D horizontal, which will remove the tool marks of the roughing operation and finish the inside of the spinner to its final dimensions. It uses the same tool and settings, but the tool path is very different. It's a little slower, but leaves behind a surface that feels as smooth as glass. The next two operations are a 2D contour, which will finish sizing the bearing pocket and do a finish pass around the outside of the spinner. Tool and settings are the same, but you'd be amazed how much difference it makes doing this finishing operation as compared to the roughing operation at the beginning. All the curved surfaces had facets before, and this is done, they will be smooth and rounded. The final operation is a 2D chamfer, which will remove the sharp edges of the machining process. The tool is a Lakeshore Carbide spot chamfer drill, 1/4 inch diameter, with a 90-degree taper. It's spinning at 5100 RPM and is moving at 36 inches per minute for a chip load of 3.5 thousandths per tooth. So that's the first stop. Getting to this point cost 2 end mills, 4 wasted workpieces, and sadly a Heimer probe tip, but now it's working and the problems have been worked out. The process time is very long at 47 minutes. This isn't a Haas, but it can do better. There will be improvements in the future to reduce that time, as well as adding the 5/8 by 32 threads to the bearing pocket. Next up is to do the second op to remove the flange and profile the web and hub of the spinner. And eventually the bearing retainer cup that will thread into the spinner bearing pocket will get designed and the cam worked out. Until then, have a great day, and thanks for watching.